Family of absolute value functions, part 404, brought to you by themathprime.com. Previously, we took a look at changing the values of C and B. Now we are going to take a look at changing the values of M. Again, here we have a table of values of X and Y. This column representing the values of X. This column here representing the values of Y for the parent function. And this column here representing the values of the function for which the value of M is 2 in this case. So here are the two graphs, the red graph representing the function with the value of M is equal to 2, and the blue graph representing the parent function. So this is called a stretch function, where each point on the parent function is basically stretched upwards by a factor of 2 in the positive y direction. So this transformation is called the stretch function. In this example, we have taken a negative value of M, -1. The red graph again representing the value of M equals to -1, and the blue graph representing the parent function. The two functions are mirror images of each other. If you were to consider an imaginary mirror along the x-axis, then each point on the red graph has a corresponding mirror image on the parent function graph. Therefore, this transformation is also sometimes known as a mirror transformation, though it still belongs to the stretch family of transformations. Now let's take a look at a fractional value of M, 0.5 or half. It's still a positive number, but it's less than 1. The red function, or the red graph here, represents the function with a value of M equal to half, and the blue graph represents the parent function. The red graph basically looks like somebody took the blue graph and squashed it down towards the x-axis. So this too is a stretch function, but sometimes also known as a compression transformation. So this is just a stretch transformation in the y direction, but one in which every point is basically compressed down by a factor of a half. That concludes this module from themathprime.com.